Alright, welcome to Unit 7, Properties of Logarithms Review. Now, number 1, it says solve for x when given the natural log of 2x plus the natural log of 5x is equal to 3. Now, let's go ahead and note this off to the side that whenever we see the natural log of anything, let's just call it the natural log of x, this is equivalent of writing just the word log with a base of e to the x. So, if you'll recall from our properties of logarithms, whenever we are adding two logarithms, what we really can do is we can combine them to multiply what's on the inside. So we can rewrite this as the natural log of, and on the inside, we can say, okay, well, our first quantity was 2x times our second quantity, which is 5x. And of course, this will still equal 3. Now, as I continue to write this, I'll write the natural log of 2x times 5x, which is 10x squared, is equal to 3. And from here, well, let's go back to this little log, base e. We know that the natural log is actually a log with a base of e. So what does this allow us to do? It allows us to raise everything into the exponent of an e, and what we do on the left, we now can do on the right. And in this case, e to the power of the natural log, those two things cancel, and we're left with 10x squared is equal to e to the power of 3. Now, e to the power of 3, you can go to any calculator and do that, will be 20.09. 20.09. At this point, we can divide both sides by 10, and once our 10 cancels, we'll have x squared is equal to 2.01 if we round after two decimals. And from here, we just ask ourselves, how do we get rid of this square? And the opposite of a square is, of course, the square root. And so we'll say x is equal to 1.42 if I round to the nearest hundredths place. Alright, go ahead, pause the video, finish taking notes. Let's move on to our second example. Okay, here in example 2, we want to solve for x when given a log base 9 of x squared plus 8x plus 12 minus log base 9 of x plus 6 is equal to 3. Now this is one that you probably feel a little bit more familiar with. Remember, whenever we are subtracting, this actually allows us to divide these two quantities. So I can rewrite this as a log base 9 of, and I'll use a big parenthesis here to go ahead and write my first quantity, x squared plus 8x plus 12 divided by x plus 6. Now from here, still set equal to 3, what I want to do is I always want to try and factor what's on top. So I can do the log base 9 of, once again, big parentheses, and on the inside, let's go ahead and see if we can factor this, switch it up to orange right here, into x plus or minus something times x plus or minus something. And you have to determine what two numbers add up to be this middle term and multiply to be that last term. Well, I know that 6 plus 2 is equal to 12, and 6 times 2 is equal to 12, and 6 plus 2 is equal to 8. On the bottom, I still have my x plus 6, and remember, whenever we have a factor that is the same on the top as it is on the bottom, those two things can cancel. This now allows us to write our remaining equation as the log base 9 of x plus 2 is equal to 3. Now from here, I know that in order to get rid of a log base 9, I raise everything into the power of that number in the base, so everything goes into the exponent of a 9. And what I do to the left, I of course do to the right. Now at this point, those two things cancel, and I am simply left with this. X plus 2 is equal to, and 9 cubed, I hope that you have begun to memorize this. 9 cubed is 729. At this point, I can subtract 2 from both sides, minus 2, and we get x is equal to 727. Pause the video, finish taking notes. Let's move on to our final example. Okay, welcome to example 3, where we are going to solve for x when the natural log of x squared minus 25 minus the natural log of x plus 5 is equal to 5. Now I show you this one to show you that it actually has all the same properties of our last problem. Whenever we see this subtraction, it's telling us that we want to divide by these two quantities on the inside. So I can write the natural log of quantity 1, x squared, minus 25, divided by the quantity 2, x plus 5, and of course this is equal to 5. Now from here, when I go ahead and write my natural log, I want to see, can I factor the numerator? And one of the things that I would tell you is that you're really trying to ask this question. Hey, we know that x times x is of course always x squared, but what two things multiply to be negative 25? And if there's no x term in the middle, what two things multiply to be negative 25 but add up to be 0? Well, of course, it's x minus 5 and x plus 5, because negative 5 plus 5 is 0, and negative 5 times 5 is negative 25. And this is, of course, over x plus 5 is equal to 5. Now, because I have an x plus 5 on the top and bottom, those two things cancel, and I'm left with the natural log of x minus 5 is equal to 5. Now, you ask yourself, how do you get rid of a natural log? And of course, the easy answer is we raise it to the power of e. And what we do to the left, we now have to do to the right. E to the natural log, those two things cancel, and we're left over with this. We're left over with x minus 5 is equal to, you'll have to go to a calculator, I'll do that right now, and e to the 5th power is actually equal to 148.41. Let me make that better, 8. Now from there, all we have to do is add 5 to both sides, plus 5, and what we'll get should be x is equal to 153.41. Alright, I hope this was helpful, and I'll see y'all in our level 4 video in a moment.